All right. We go over the writing the solubility product or determining the yeah, we go over this part one more time. All right. So writing the solubility product. So when you have two ions, the cation and anion, it's pretty simple. The KSP is just cation concentration times anion concentration. Now, if you have one cation and three of the anions, then it is Fe3 plus times OH minus cubed, right? Because when you split it up on the other side, you're going to form three of the OHs. If you have, again, same thing, you have two of those anions, so then it's Pb2 plus I minus squared. If you have, again, like AgCl, one of each, then it's just Ba2 plus times SO4 2 minus. Here you have Pb, the charge opposites, remember the charge on the Pb is 2 plus, but you have three of this, so that's cubed. And then you have the charge on the ASO4 is 3 negative, but there's 2 of it, so that's squared, okay? Slightly complicated. Okay, now once you do know the concentration of those ions, then it's easy to calculate the KSP. If they're splitting up 1 and 1, all right, one cation, one anion, then it's basically if you have one of this, you're getting one of this and one of that. If you're 0.00048 of the calcium oxalate, you're getting 0.00048 of the calcium and 0.00048 of the oxalate. So it's just squaring those two and you get the KSP number. Now, if you have something like lead 2 iodide, which breaks up into the lead 2 ion and the 2 iodide ions, then you have to take this, you're forming one of this and two of that, right? So 0.0012 of the lead and 2 times 0.0012 of the iodide, and in the expression it's squared, so you'll have to square it, okay? So that when you work out, it comes out to be 6.9 times 10 power negative 9, okay? If you're given the KSP values and then asked to find out the solubility is these values, all right? So this was, solubility was given and you're asked to find out the KSP. This time the KSP was given and you're asked to find out these numbers, the solubility numbers, okay? So what do? You put an X since you don't know what it is, okay? So Al is going to split up into one Al, 3 plus, and the 3 OH minuses, okay? So X and 3X, but then in the expression this is going to be cubed, all right? So 3x cubed times x, that's 27x4. Calcium fluoride will break up into x and the 2x squared, okay? So 4x cubed. BaSO4 is going to break up into x squared. CuOH2 is going to be x and then the 2x squared, so 4x cubed, okay? So then what you do is take the KSP value, 4.6 times 10 power negative 33, divide it by the 27. Once you get the answer for that, after you divide this by 27, then take the fourth root of that number. That will give you x. Again here, 3.44 times 10 power negative 11 divided by 4, and then take the cube root of that answer. This is just square root. Just take the square root and you will get the value of x. Here you divide this by 4 and then take the cube root. So it will work out to look like this, all right? So divide by 27, take the fourth root, and here divide by 4, take the cube root, and the same thing over here. divide by 4, take the cube root, and here just the square root. All right, so that gives you the solubility numbers once you have the KSP values. So to summarize chapter 10, we talked about temperature, concentration, and catalyst affecting rates of reactions. All right, so those are the three main factors that can affect rates of reaction. And then we talked about equilibrium reactions, which are reversible reactions, where the rate forward and the rate reverse equalize. However, the reactant and product concentrations are constant. Okay. So when you take the ratio of the product and the reactant concentration at equilibrium, it gives you the equilibrium constant expression. All right, if you have a large Kc, it favors products. Small means reactants. Le Chatelier's principle is about how the equilibrium shifts depending on what kind of constraint you added to the equilibrium. Shifts in concentration, shifts in volume, or shifts in temperature. Okay. And that's the end. And we also went into section 10.6, where we talked about the reaction quotient, how to predict the direction of reaction, and finally the solubility product. Okay, so that's the end of chapter 10, and the end of these videos for chapter 10.